is a physical quantity that changes the state of rest or the velocity of a body. For example, magnetic force and gravitational force. Force applied on an object can change the velocity and shape of an object. Forces can be balanced as well as unbalanced. Unbalanced forces are forces that cause change in motion. They act on an object and change its speed or direction of motion, or both. If two or more forces acting on the same object keep the object in equilibrium position or in the same state, then the forces are called balanced forces. These forces do not cause any change in motion. Galileo opposed the idea of Greek philosophers that a moving object comes to rest when no forces act on them. Being inspired by Galileo's work, Sir Isaac Newton worked on it and proposed the laws of motion. Isaac Newton was a physicist, mathematician, astronomer, and natural philosopher. He wrote the famous book Principia Mathematica and developed a branch of mathematics, calculus. He also prepared the first reflecting telescope. Sir Isaac Newton studied the motion of objects and the factors related to change in velocity and gave 3 laws of motion. Newton's first law of motion is also known as the law of inertia. It is based on the inventions of Galileo. Newton's first law of motion states that an object at rest tends to stay at rest, and that an object in uniform motion tends to stay in uniform motion unless acted upon by a net external force. For example, to accelerate an object, an external unbalanced force is necessary. That means, to change the state of rest or state of motion of an object, an unbalanced force must act on it. The resistance required to change the state of motion depends upon the mass of the objects. So, it is easier to change the velocity of lighter objects than that of heavier objects. Large or heavy objects have more inertia than lighter objects. According to Newton's second law of motion, the acceleration of a body is directly proportional to and is in the same direction as the net force acting on the body and inversely proportional to its mass. Let m be the mass of a body, F be the resultant force acting on it, and A be the acceleration. According to the Newton's second law of motion, acceleration in the direction of force is directly proportional to the force. Therefore, A is directly proportional to F. Let this be equation 1. acceleration is inversely proportional to the mass. Therefore, A inversely proportional to m. Let this be equation 2. By combining 1 and 2, we get acceleration A is directly proportional to force F upon mass m, or A is equal to K multiplied by F upon m, where K is constant. If the SI unit of mass is 1 kg and SI unit of acceleration is 1 meter per second square, then the value of K will become numerically 1. Thus, we can mathematically state Newton's second law of motion as F is equal to m multiplied by A. The SI unit of force is kilogram meter per second square, or Newton, or N. The product of mass and velocity of the body is called the momentum of the body. The momentum is denoted by the letter P. A body of mass m moving with linear velocity v, the linear momentum is given as P is equal to mv. The SI unit of momentum is kilogram meter per second. Thus, Newton's second law of motion can also be stated as rate of change of momentum is directly proportional to the impressed force and takes place in the direction of the application of the force. Newton's third law of motion states that to every action there is always an equal and opposite reaction. Whenever an object pushes another object, the latter gets pushed back in the opposite direction equally hard. Thus, force always exists as a pair. However, the action and reaction do not act on the same body. When a bullet is fired from a gun, the bullet goes ahead and the gun is pushed backward. The force applied by the gun on the bullet is the action, whereas the force applied by the bullet in backward direction is the reaction. A rocket also works based on Newton's third law of motion. The gas produced by the combustion of fuel comes out with tremendous speed from a nozzle. As a result, the rocket is pushed up.